I'm going to do a presentation on the processes of mass wasting. First, the definition. Mass wasting is the downslope movement, and it's depending on how much gravity there is. Water does play an influence, but gravity is the most important factor for mass wasting. Some more determining factors: the slope stability, which again is determined most by gravity, and then the amount of friction that is against that gravity, and then the angle of repose, which is the highest angle before that mass movement occurs. And I'll explain that a little bit more in a little bit. But the type of material is very important, whether it's rock, soil, sediment, and if it's loose or heavy, and also the water saturation. So the more water there is, it might be easier for materials to move down a slope. So how does it happen? This picture shows a rock and the slide component, which maybe is how much water there is or how much gravity is pulling down, and then the stick component, which is the friction against that gravity. So when gravity wins, which is most often gravity does win, when gravity exceeds that friction on the slope, then that material does begin to move. And the shear strength resists the movement, but if gravity is too strong, the object loses friction and therefore will move down the slope. Here we go with angle of repose again then. So the steepness of a slope is an important factor, and the steeper the slope then, the more gravity that's pulling down on the materials. And the angle of repose is the steepest angle the slope can maintain without collapse. So when it gets too steep, the materials are inevitably going to flow. And that's usually 25 to 40 degree angles. So weathering and climate. Weathering, which is often wind and water erosion, definitely weakens surfaces and it decomposes the material on those surfaces. Loose materials are the most susceptible and often are the first to move. Triggering events. They will enhance the likelihood of mass wasting, and most mass movements are triggered by a force that disrupts slope equilibrium. So these things like earthquakes, snow melt, and heavy rainstorms. And again, it's because that slope equilibrium is really unstable with events that add extra water or add earthquakes, which shake the whole ground. Vegetation actually increases slope stability because roots can get into the soil, say like along a bank of a river, and they'll actually kind of solidify that slope momentarily, and when there's more water, then the slope won't just give away because that vegetation is holding it up. So criteria for mass wasting: first you have your type of material, which will be, the rock, the soil, your sand grains, mud, whatever it may be, and then the type of movement that occurs, whether that material falls, slides, slumps, flows, or creeps, and then how fast that happens, the rate. So is it fast, is it slow? And sometimes it's actually not even visible. So first we have flows, which are actually very rapid. This is what most people may think of when they think of mass wasting event. So a lot of rock all of a sudden will just come crashing down a mountain. And like I said, earthquakes can definitely trigger something like this. A slump, which actually just looks like a flow of material, but it actually goes along a curved plane of failure. A flow here can be slow to rapid if you think about the material. Debris flow might just kind of go down with a little bit of water, but add a bunch of water and then turning into a mud flow, and those can happen at rapid speeds. And as you can see on this diagram, it says a lobate forms, which is actually that kind of like centered circular end point there as the material goes down the mountain or the hill, the slope. Solifluction actually occurs in areas with permafrost, which is permanently frozen ground, but say in the summer when that ice melts up, that top surface will begin to flow or move. And creep, which is actually the slowest form of movement, mass wasting, is usually actually not even visible if you're just looking at it, but if there's fences or phone poles or retaining walls, they'll actually start to bend with that creep, and you'll see tilted trees, etc. And it's actually the only visible sign of creep, but it's one of the most devastating forms of mass wasting. So how do we control mass wasting? It's a natural event, so it's not like we can just stop it from happening, but there are things we can do to slow it down, and those those include improved drainage, so again, adding vegetation or gutters, anything to kind of slow the water that's coming down. Also decreasing the slope, so if people go in and they'll actually cut into slope and take some of the soil out and fill it in to make it less steep, then the gravity there won't be as strong on those materials. And benching actually cuts little like divots into the slope side, which decreases the slope. And sometimes they build retaining walls along roads and bridges, which actually will stop materials from going onto a road surface and at least slows down that mass movement. And that is all. These are my references. I took a geomorphology class, and I'm currently taking a geology class, which covers what I talked about today, and the images from clip art. Thank you.